So what if I told you that 10 people could save the lives of 10 million? That is possible with the power of data science. Now the problem is that today, when we think about data science, when we think about big data, we think about these amazing algorithms that enable millions of people to decide which episode of House of Cards to watch on Netflix tonight. We think about the algorithmic trading techniques used by today's hedge funds. We think about all the debates on government surveillance and privacy. So we think about all these things that seem kind of abstract and kind of scary, and so we don't really have the best idea of what data science can do. But data science can be used for much, much more than that. And the same techniques that made the fortune of the industry can be used to make better, data-driven decisions that affect not just the user experience of millions of people on the website, but also the lives of millions of real people. And I'll show you how. So what is, no, you have this thing here. What is data science? Every day, we create billions upon billions of gigabytes of data through our daily activity. Now, we go on Facebook, we browse things to shop for on Amazon, we go on Google Maps to find where the hell this damn conference is located. And so we create a lot of data. And so data science is this new discipline at the intersection of mathematics, software engineering, and operations research that would take in all these data and turn it into something useful. It is often synonymous with machine learning, ou apprentissage machine en français, that consists of creating algorithms that can learn automatically from data, pretty much in the same way that you and I, human beings, can base our judgments based on our daily experience. So we do pattern recognition based on what we see every day, and this is pretty much what we try to do with algorithms. And for those who think that it sounds a little bit futuristic, that it sounds a little bit abstract, this is not a new idea. For decades, operations research has enabled businesses to optimize processes with mathematics. But the thing that is different today is that for the first time in our history, we have an enormous amount of data, and we have the computational power to actually make something out of it. And so what we're able to do now is to create algorithms that can make decisions at scale and in real time. And so when we think about big data, when we talk about data science, it really means algorithms that can learn based on data, and that can use it to make decisions, or that can inform decisions in real time and at scale. So let's use a few examples. Who here in the room has already used an Uber? Qui a déjà pris un Uber ici? So Uber collects data on every passenger, every request, and every destination. They're then able to use that information to predict where and when requests are more likely to happen, and then to optimize the dispatch of their taxis in real time. But hang on, wait a second. Every day, thousands of people die waiting for ambulances. And if you want to revamp emergency response infrastructure, it will literally cost you billions of dollars. But if we can use data to optimize taxi dispatch, what prevents us from doing the same thing for ambulances and fire trucks and police cars? The answer is nothing. With algorithms, we can reduce overall wait times, we can save lives, and we can even save some money on the way. And that is the power of algorithms. And by the way, you might have wondered what this ugly-looking slide behind me is supposed to represent. It's actually a data dump from the San Francisco Fire Department with whom we work with. And this is a day in the life of the San Francisco Fire Department. It looks a bit ugly right now, but if you analyze it, this is what it looks like. So this is a visualization that we created one rainy afternoon in San Francisco. There aren't that many. And that helps us better understand what's actually happening. So here the moving dots are ambulances, and the red and blue dots that pop up every now and then are emergency calls, depending on their level of priority. It looks better this way, doesn't it? OK, so let's use another example. Who here has already used an online dating website like Musique or eHarmony? Don't be afraid. Happens to everyone. So dating websites use algorithms that can take information about your personal characteristics and use them to recommend you people you have a high likelihood of compatibility with. For example, they can look at criteria like, are you a cat or a dog person? Do you like which movie? How tall are you? And then use all that data, use all these criteria to match you with people you're likely to have a strong connection with. But love is not the only matching algorithm. Musique n'a pas le monopole du cœur. And for example, you have other related problems, like, for example, professional matching. And these are problems of an unfathomable scale. So here I just pulled up the numbers for Pôle emploi, which is the institution in French that is charged of, does the task of managing the French unemployment system. And these are just today's numbers, and I'm using them as an example, just to give you an idea of the size of the problem. So the question is, what if I told you that you could take all these huge-looking numbers and save billions of dollars a year in operating costs, and even reduce the unemployment rate in the entire country by 10%? It sounds a little bit far-fetched, but it's actually not. We can use algorithms in much the same way that dating websites, we use these algorithms to match people, to match job seekers with professional opportunities in a potentially faster and more optimal way. The one thing that algorithms are really good at is to look at the system as a whole and not just look at every single case by itself. And so they're able to make decisions on the whole that can be more efficient. And if there's one thing that I want you to retain today, is that if you talk about systems on that scale, if you talk about systems that affect millions of people and that have an order of magnitude of billions of dollars, even an efficiency improvement of 5, 10%, even a small improvement in efficiency, can lead to huge impact, both in terms of human impact and in terms of financial impact. And it turns out that making these small efficiency improvements is really what data is great at. So, it sounds kind of great. And this is what led me to realize that data science can be used not just for improving ad click-through rates, but also to do a tremendous amount of impact. And the problem today is that I was kind of wondering, why do we not do that? And the fact that today we have the ability to take these problems that we took for granted and to actually solve them on the large scale is something that really compelled me. And that's what I realized when I became the first data scientist at Eventbrite a few years ago. So Eventbrite, for those who are not familiar, is a ticketing platform. So it's a website that allows people to create events, sell tickets, and it's a platform on which you have about $2 billion worth of transactions every year that flow through the platform. And among other things, one of the things that I built there was a fraud detection system that was able to detect 99.8% of fraudulent transactions on Eventbrite. And I thought to myself, whoa, if I'm able to build an algorithm that can save my company millions of dollars, and if I'm able to make a quantifiable improvement on our fraud detection problem with just a few lines of code, what prevents us from doing the same thing to improve health outcomes, to improve criminal justice decisions, or even just simply to save lives? So I guess my whole life I've been trying to find a way to do impact. So ever since I was a kid, grew up in a poor neighborhood in France from Chinese immigrants who actually did Tiananmen, and after the Tiananmen Square protests, left China for France. And when I was growing up, they used to tell me stories about tanks and how they'd be fleeing the square, and as they fled, people would get shot in the back. And I remember asking them, why would you go through all these sacrifices? Why would you do all that? And for them, the answer was simple. It's because if you can change a system at the scale of China, even a small impact, even if you can change the Chinese public policy by a little bit, it's a little bit times the number of people in China, and there are a lot of them. So a little bit of impact times 1.5 billion people equals a tremendous amount of impact. And so my whole life, I've been trying to find a way to achieve the same effect, to achieve the same leverage, And I couldn't quite find that. So I did a lot of things, and I studied political science at Sciences Po. I thought that politics was the answer. At least for me, it wasn't. I ended up becoming jaded and moved towards finance and science. And I ended up studying mathematics at Berkeley, and this is where I realized that it is possible to use your brain to do something useful and to create something of value. And it sounds a little bit cliche, but I actually remember that day where I was actually volunteering at the homeless shelter. And I thought, well, it's cool, I can do impact one bowl of soup at a time. It feels good. Girls love it. It's amazing. People think you're a great guy. But I'm not really solving the problem. I'm just contributing one bowl of soup at a time. And I saw that you actually had a lot of inefficiencies in terms of the planning and the whole management of the food stocks. And that if you could solve these inefficiencies, you could actually feed 20% more people on the same budget. And that's when it clicked for me. Now the problem is that in Silicon Valley, we do have an arrogance problem. And yes, we're pretty arrogant. We think that because we're from Silicon Valley, we can do everything better than everyone else. And sometimes it's true. Often it's true. But not always. And we seldom think about social challenges. And when we do, we often fail to think about all the human obstacles, all the political obstacles, all the operational obstacles that prevent us from truly solving the problem. And very often, you actually have a good reason for why these problems are the way they are. You can't just go in there and disrupt something the scale of Pôle emploi in an afternoon. And what we realize is that a lot of the technology nonprofits in the space tended to focus mostly on hackathons, volunteer projects, and it's great. It gets people interested in doing social impact. But what it is not able to do is to build operational solutions, meaning solutions that are working on the field for projects at this scale. And especially when you talk about data, you have a host of different problems that you have to take into consideration if you want to do anything. I can give you two examples. I guess on the lower end of the spectrum, you have organizations that might not really understand what data science is. And so we were actually approached in our early days by a nonprofit, I won't name them, that came to us and said, hey, Paul, come help us. We have 10 years worth of data. We have amazing insights. We could do a lot with your help. And so we went there, and we realized that what they meant by we have 10 years worth of data is that they actually had 10 data points. They had aggregated the data at the year level. So what do you want to do with that? How do you even start talking to them about machine learning? That's one type of problem. The other type of problem, and that one is much more important and much harder to solve, is sometimes you'll get into really thorny issues like criminal justice. On the surface, it sounds like a match made in heaven, right? Data science is great at helping people make better decisions. That's where the whole data-driven decision-making comes from. And criminal justice is all about making decisions. You want to decide who goes to prison, who doesn't, who gets paroled, who doesn't, who has to sit in jail while they're waiting sentencing. All these are decision problems, and all these could theoretically be made better with data. But the problem is that even if you have a solution that works, how do you go about collecting that data? Because the software and the whole vendor ecosystem in criminal justice is extremely terrible. They date from the 1970s. And sometimes you don't really have data. And very often they come stuck on some guy's computer in Illinois. You don't really have a central warehouse. So how do you get the data? How do you convince people? How do you convince judges, district attorneys, juries, that they can trust this little black box that tells them what to do to make decisions they've been making for decades? How do you even go around all the restrictions on collecting such sensitive data? And even if you have something that works, and if you have something that's implementable, and that you can actually roll out and make it so that you can interface with all the software systems, how do you make sure that your algorithm does not have some kind of hidden bias? How do you make sure they don't have any kind of for example, systematic error that says if your name is Paul and you're this tall and you come from this place and you have these and that factor, you will never get paroled. That would be terrible. If you want to build an algorithm that makes decisions on the lives of people, even if on the whole you can make better decisions, even if on the whole you can make a lot of impact by streamlining all these decision processes, if you have one single flaw, if you have one single systematic bias, it's unacceptable. And so if you want to do this, you actually have to work in the long run in close partnership with these institutions that might have a very different culture than you do, people who don't come from Silicon Valley. And you need to understand all the complexity of everything that's at stake. You need to understand the subtlety of everything that, that they're working on. In criminal justice, people have been studying criminology for decades. It's not something that you can pick up just in a weekend. And so you need to work with them in depth over a long period of time to accompany them in this process of modernization. And so this is what we realized, and this is what prompted us to start Base Impact about a year ago. So we are an NGO, we're a nonprofit that uses data science to build operational solutions for big social problems. We started small, not really knowing where to go. And then things kind of picked up. We got through Y Combinator as the only nonprofit. We hired a bunch of great people. We got a bunch of pretty cool US government contracts. And here we are. So we are hiring away people from Google, Facebook, Uber, top engineers and academics, and we tell them to come here to make less money. I don't know why they would do that. But anyway, we somehow got these people, and we're trying to solve social problems. And the thing that makes the difference is that we are actually bridging the gap between politics and technology. So we are working in close partnership with all these social institutions like governments and other NGOs to build operational solutions. For example, we're working with Sutter Health, which is the biggest hospital network in the US. C'est un peu comme le APHP des États-Unis. We're working with Sutter Health to build open source predictive software that can predict the likelihood of readmissions and complications for patients. So for those who don't know, patient readmission is one of the largest problems in healthcare today. So it's basically when someone gets discharged from the hospital, and then within 30 days they either fall sick again or they have some complication, and then they end up coming back to the hospital. And obviously that's not great because it adds additional strain on the healthcare system. It costs a lot of money. And well, if you came in for a heart attack and you're readmitted, usually means something that's not that great for you either. And so what we're doing is we're taking data from electronic medical record systems. We're working with all these hospitals to take the data and then look at a patient's medical history, to look at their clinical symptoms, to look at their demographic factors, to predict in real time their risk of readmission, and then target them towards like an intervention program or towards some kind of treatment that is appropriate before they even leave the doctor's office. And we estimate that even if 10% of hospitals in the US alone were to use our software, we could save 300,000 years of human life a year. But that is just the beginning. From criminal justice to healthcare, through emergency systems, to international development, I hope I give you some good examples for how algorithms can be used to make the world a better place, one piece of data at a time. And so I will conclude by saying that sometimes a small idea can have a big impact if you can find the right leverage. For my parents, it was political action. But for us today, we have the power of algorithms. We have the power of the digital revolution at our fingertips. And that is our leverage. And so to answer the question, can algorithms save the world? Yes, but not by themselves. Algorithms don't save the world. Humans, like you and me, powered by algorithms, can save the world. Thank you. So I guess this is where we ask questions. Nope, no question? Yep, over here. All right. All right, thank you. En fait, on peut pas voir la salle.
Okay. Hi. You told about algorithm, about criminal cases, for example. Criminal cases are something that you can't have mistakes, errors on your results.
Yep.
So can we really have an impact on this field? Do you think we can?
Yeah. And by the way, sorry, I actually didn't see you because the way the light is is really hard to actually see if people are actually doing anything. Well, the answer is yes. So actually, there's a lot of there's a huge movement towards data-driven decision making in criminal justice. So a lot of great organizations are working towards that, and well, yeah, criminal justice as a whole is a very thorny topic, and you have a lot of things that make it difficult. But what you can do is actually pick at some kind of like sub-problems that you can actually solve, and actually use that as an opportunity to say that if you want to change things with data, you usually have to have a problem that is well-defined. You can't just say data will do everything. You have to pick like one metric that you want to optimize. And so you have a bunch of sub-problems, like, for example, you have something called diversion. So that means when someone is due to appear on trial, because there's a lot of people who are waiting for trial, you have kind of a weeks to month-long process where they have to wait for the trial. So the question is, what do you do with them? Do you put them in jail temporarily? Do you send them to house arrest? Can they just get away with community service? And that right now is really hard to do, and we don't really have the infrastructure to actually make that decision, and so that's why people actually end up sitting in jail, and you have jails that are way overcrowded. And so one example of a sub-problem is just looking at risk assessment for people who are awaiting trial. So trying to predict the risk of recidivism, trying to predict the risk that someone is dangerous, basically, so that we can say, well, this guy is a low risk, this guy will not commit a crime in the 6 weeks before trial, so he can just go home. Right? So yeah, that's one example.
Okay, thanks.
And anyone else? You can just start speaking, actually, because I can't see you from here. Nope. Cool.
So yeah, I was saying, what does really prevent us today from having algorithms, for example, in the French system? Why is it still so tricky and hard to have solutions for people who are, looking for a job, for example?
Yeah, well, we give a lot of shit, to public institutions, but they actually have a lot of things to take into account, right? In France, you have the CNIL, la Commission nationale pour l'information et liberté, un truc comme ça. You have a lot of regulations about what you can and cannot do with data, and that's for good reason, right? Because you don't want individual data to be misused, right? So you have a lot of real problems, and then you have some cultural problems. Like, for example, even here in Silicon Valley, well, I guess even there in Silicon Valley, at tech companies, it's difficult to actually build a new product. It's difficult to implement something new. So think about how it is for institutions that are like 300 years old and they've been doing the same things for decades, right? It takes some time to really shift minds. And I think the problem today is that, data science is very new, and the people who talk about doing data science tend to have a kind of like a confrontational approach when they talk to these people. They're like, you kind of suck, I can do things better than you can, and I know you've been doing this for 30 years, but yeah, it's actually crap. And it's not really the best way to do that. And you have to actually go there and help them understand, and sometimes they have to help you understand that there's a reason why things are done the way they are. And I think when you do that, the dialogue is much easier. For example, when we go approach a government, the reason we've been able to get government contracts in a few months, even though we had no clue about how to do government sales. I don't look like a business consultant. The thing is that you can actually have kind of a discussion about doing a partnership, about doing some kind of initiative together. Right? It's not about you trying to sell them something. It's not about you trying to disrupt something, it's just you trying to help, right? And I will say that you cannot have different problems. One is that it's extremely difficult to work with governments. So the people who end up working with governments are the people who you would not want to work for governments. So the people that can optimize for getting these contracts as opposed to really solving the problems. I won't name anyone, but you can imagine. You have tech companies that are trying to sell products, and for them it's actually really difficult to get their hands on these sensitive data. For example, the readmission project I was talking about for hospitals, a lot of for-profits have been doing it because you have a huge financial incentive. The problem is that you have a lot of commercial liability questions around data. Hospitals cannot just use data, give it to a for-profit so that they can build some commercial product out of it. It's possible, but it's very difficult. So, in all of that, that's kind of like where we saw that being an NGO, being a non-profit could actually help move the status quo. And the problem is that you look at technology nonprofits, you fall into the opposite problem, which I was talking about, which is that technology nonprofits tend to focus mostly on what makes engineers feel good, and I mean, it's great, but the problem is that what's interesting to engineers is not often what's useful. And so, you have to have people who are willing to spend 3-6 months just trying to get the data or trying to navigate through the bureaucracy and sign 20,000 forms. I guess if you want to really solve a problem, you need all these components, and it's been really hard to find all these components in a single entity. And well, I guess that's kind of what we're trying to do.
Okay, thank you.
Ouais. Bon, on me dit que j'ai plus de temps, donc you can talk to me afterwards. Just find me in the hall. Thank you.